Alright, so in our previous video, we were talking about slope and how to find the slope using the slope formula. And so we've talked about most lines and it being a positive or a negative slope, but we do have some lines that are going to have what we call zero slope or no slope. And so if the slope of a vertical line, if we have a vertical line, the slope of it is always going to be considered undefined or no slope. So think about this. You've got this vertical line runs up and down. If you think about rise and run, vertical change compared to horizontal change, well, it changes vertically some amount, but it does not change horizontally. So if we were going to write that as a fraction, we would say the vertical change, you can pick a number, we'll say it's 3, divided by the horizontal change, the right and left change, which is in this case 0, and 3 divided by 0, you can't do. It's undefined. And so a vertical line has what we call an undefined slope. On the flip side of that, though, a horizontal line has what we call zero slope. Again, if you were to think about rise and run, if you were going to go from this point, say, to this point, well, you wouldn't rise any. You don't go up or down, and so the rise would be 0. And then you would run some amount, we'll call it 4, just for the sake of a number. And 0 divided by 4 is 0. Now, you have been lied to all your life. People have told you that 0 and nothing are the same thing. That is not always true. Because in this example, a 0 slope, 0 is a number, that is completely different from having no slope or an undefined slope. And so this is one of the slope problems where people get confused, is because they've always been told no slope and 0 slope, they're the same, but they're not. And so it's really important you understand the difference. And I'll give you a way to remember that more in just a few minutes. So what I want us to do is to continue to find the slope using the slope formula. This is very similar to what we did previously, but some of this gets a little bit different than some that we've seen. So remember, our slope formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And so we're going to take our numbers, we're going to substitute those in. And so when we do, the y sub 2 is negative 6 minus y sub 1, which is 4. Again, be careful with your signs here. And then on the bottom, x sub 2 is 2 minus x sub 1, which is a negative 2. Now, that minus a negative does become positive. And so as we simplify this, we have negative 10 on top. And then 2 plus 2 is 4 on the bottom. And that does simplify to negative 5 over 2. So there's our slope. Now, as we've mentioned in previous videos, I do want us to begin to get this mental picture. What does this mean when we say we have a slope of negative 5 over 2? Well, in this case, what it means, if you have a point on this line, for every 5 units you go down, you're going to go right 2 units, and you're going to have another point on this line. And so our line looks kind of like this from a steepness standpoint. Okay? Now, look at the next two, because these are a little bit different. So, when we find the slope, again using the slope formula, we're going to have 8 minus 8 divided by 5 minus negative 3. Again, that minus a negative makes it 3 positive. And so we're going to have 0 over 8, which is 0. Now, again, what does that line look like? Well, from this mental picture standpoint, it means that if you have a point on this line, and I'll use the fraction as an example, you don't go up any or down any because the rise is 0, but you run 8. So 1, 2, 3, 4, 5, 6, 7, 8. And so when you do that, you see that your line has to be horizontal, which is what we mentioned a few minutes ago. Now, on the next one, again using our slope formula, oh wait, there's the slope. We have y sub 2, which is 10, minus negative 10 over negative 4 minus negative 4. Again, the minus and negative makes the 10 and 4 positive. So 10 plus 10 is 20. Negative 4 plus 4 is 0. And so again, that is an undefined slope. We could also refer to that as no slope. So either of those terms are fine. Your book will, and your math lab, use undefined. I'm going to use no slope and undefined both sort of interchangeably. Now, when we look at that from a mental picture standpoint, again, we can use that fraction as the example. It means that if we have a point on this line that we're talking about, for every, I'll start here at the bottom, for every 20 units that we go up, we have a point on the line, so we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It'd be way up here somewhere. And we don't have to draw the line that high. But for every 20 units you change vertically, you're not changing any horizontally. So in other words, this is just a vertical line. And again, we don't have to draw the line all the way up to that point because it is vertical and would go through that. If it did have a slope, if it were 20 over 1, for example, well, then you would have to go up 20 and write 1 to see how steep that is. Now, those are two that are somewhat difficult for people to remember. So I'm going to give you a couple of ways in just a few minutes that you can remember that. Before we get to how to remember that type of slope, the zero versus no slope, we need to talk about how to find the slope from the equation. So up to this point, we have found the slope with the slope formula. And we've talked about the rise over run and kind of how that works. But another way we can find slope is from the equation. And so I've told you in the past that equations have solutions. Those solutions are order pairs. Those order pairs go on a graph. And when you make the graph represents every solution to these equations because most of these have an infinite number of solutions. And so because of that, we can find the slope from the graph, which would be literally counting rise over run, which we're not going to focus on. We could find the slope from the slope formula, which we just did. And then we can also find it from the equation. And so if we're going to find it from the equation, we want to be able to take our equation and put it in this form, y equals mx plus b. It's called slope-intercept form. And it's called slope-intercept not because somebody said, you know what, that'd be a cool name for it, but because it literally tells us the slope, which is this m number, and the y-intercept, which we'll talk about later. And so if we can take our equation and put it in this form, then we can find this number with x. X is not part of the slope, so don't tell me the slope is 2/3 x, for example. It's just 2/3. And so we can take our equation, solve for x, and solve for y, and find the number with x, and that will tell us our slope. And so what we're going to do here is we're going to take this equation, and I'm going to rewrite it so I have a little more room. And we need to solve for y. And so to do that, we're going to move that 2x, that whole term, to the other side. And so we'll subtract it. And so 2x minus 2x is 0, which is what we wanted to happen. And we get negative 5y is equal to negative 2x plus 10. And then we need to divide by negative 5. And we'll find out that y is equal to a positive 2/5 x. It is positive because of negative divided by negative. And then minus 2. And so the question is, well, what's our slope? Well, the slope of this one is this number with x, in this case, the 2/5. So there's our slope. Now, again, I think it's really important that you, in your mind, have a mental picture of what does a line with this steepness look like. And so again, if we do a little sketch, it means that if we have a point on this line, For every 2 units that we go up, we're going to go right 5 units. And we'll have another point on this line. And so our line looks sort of like that. Now, I'm focused on you finding the slope, but I would like for you to be able to do the sketch, because later when we graph with slope, it's going to be easy to graph knowing, okay, here's what it should look like. Now just where does it go on the coordinate plane? Take a few seconds, pause the video, try the next one on your own. I'll give you 3 seconds to pause the video. Okay, so hopefully you paused the video, you worked this one, found the slope. And so to find the slope, we're going to solve for y. So we're going to subtract 3x on both sides. And we're going to get 2y is equal to negative 3x plus 9. And then we'll divide by 2. And we'll find out y is equal to a negative 3/2 x plus 9 over 2. Now, again, we don't care about that other number. We're not dealing with it yet. We just want to know the slope. And again, the slope is this number with x. And so it's negative 3 over 2. Now, from a mental picture, what does it look like? Well, it means that if we have a point on this line, we're going to go down 3. We're going to go right 2, and there's another point on our line. And so again, when we connect those, our line looks something like that. If you have any questions about that, please let me know. It is solving for y and then finding that number with x. Now, as we jump into talking about how to graph, we have found slope. We know how to find the slope, and we've done this mental picture, which is going to be really helpful to us, because when we talk about graphing, we literally have 2 ways to put a graph on paper. We can either find 2 points and plot them and connect the line, or we can find 1 point, plot it, use the slope to find a second point and a third point, and so on. And so we're going to do that here in just a minute. But before we get into using the equation to do that, we have talked about how to just plot points. We made our table. That's what we did when we found our intercepts a couple videos ago. We did that as well. Now, though, we're going to focus on using the slope. And so you may not have noticed it, but on every one of these problems that we've done recently, when I've done this mental picture, so when I take this mental picture and I sketch that, every single time I have started with, if you have a point on the line, if you have a point on the line, if you have a point on the line. And I say that over and over again because it's really important. If we're going to graph with the slope, we have to start with a point on the line. And so you'll notice in this first problem, it says to graph the line passing through the point negative 3, negative 2, that has a slope of 1/2. Well, we're going to start with the point on the line. So in this case, negative 3, negative 2. Go left 3 and down 2. And then we're going to use the slope to find another point. So when you plot that original point, you're starting at the origin, just plotting a point. And then the slope allows you to find the next point. When you use the slope, do not go back to the origin. Absolutely do not go back to the origin. You're going to start with the point on the line. Okay, that's really important because I see people every semester that will go back to the origin and they'll try to use their slope to find a point. Start with the point on the line. And so we know that a slope of 1/2 means that if we have a point on that line, which we now do, we can go up 1, we can go right 2, and we should have another point on that line. And I would suggest doing 3 points. Again, mainly as a checkpoint, but there's some reasons for that. So if you do that again, go up 1 and right 2, then you're going to see all 3 of those points lie on the same line. And so that is what our line should look like. Now, the reason I suggest doing 3 points, if you plotted the first point, and I'm going to do this in blue, I'll tell you what I'm doing in green. If you started with this first point, and then you went to the origin to do your slope, and you went up 1 and right 2, you would have a point here. Okay, this is not right, so don't do this in your notes. And then if you went up 1 and right 2 again, you would have another point here. Well, these 3 points that I have in green do not form a line. They're not a straight path. And so when you do that third point, it should help you see that, okay, that's not going to be right because it's not on the same line. So when we find our slope, like I've done in red, we're going to start with the point on the line, use our slope to find the next point. Now, I would encourage you again to pause the video, try to graph this next one on your own, and then I'll do it for you in a second. So I'm going to give you 3 seconds to pause the video. Okay, so hopefully you've graphed this one on your own. In this case, it says that we're going to graph a line with the slope of 2/3. So again, in your mind, you got to be kind of picturing, okay, what does that mean? And it has a y-intercept of 0, -4. Now, this y-intercept is a point on the graph, right? So we have to have that. And so 0, -4 is at this point. And if our line has a slope of 2/3, it means that from that point, if we go up 2 and right 3, we should have another point on that line. So we're going to go up 1, 2, and then right 1, 2, 3. And there's our next point. And then you can do it again. If you go up 1, 2, and right 1, 2, 3, we get our third point. And again, you can see they're all on the same line. And it looks something like that. Again, mine's not perfectly straight, but you do hopefully see what it should look like.